Thank you, Paul, for an interesting description of Seafuel project. I'm right in saying there's more information about Seafuel out in the concourse where we met earlier. So
there are some pamphlets as well.
Yeah. Our next speaker is Rafael Ortiz Imedio from the University of Cantabria, an industrial technology engineer. Rafael is currently undertaking his PhD on internal combustion engines fueled by hydrogen mixtures. He's also involved in the European project Hylantic, and I would invite Rafael to tell us about this. Thank you.
Thank you very much. Good afternoon to everyone. I'm here on behalf of Dr. Rafael Ortiz, who is the coordinator of the Hylantic project, or Atlantic Network for Renewable Generation and Supply of Hydrogen to promote high energy efficiency. Hylantic project belongs to Inter-Atlantic area, the same as Seafuel, and is focused on low carbon economy. The consortium composed 4 universities: the University of Cantabria, who is the coordinator or leader, the University of Porto, the Ulster University in Belfast, and Dublin City University. We also have 2 research institutes, the CNRS in France and the LNEG in Portugal, and 5 companies, 3 from UK, Ulenco, Auriga, and Pure Energy Center, Asilva Matos in Portugal, and Apria System from Spain, represented here by Esther Santos. The budget is about 2.5 million euros. We also have many associate partners of different associations or organizations. The main goal of the Hylantic project is to establish an excellent transnational network to advance the research and development of renewable hydrogen generation and recovery from industrial waste streams. Also, we want to have innovative and safe hydrogen storage systems and the competitive implementation of high-efficient and low-cost energy systems with fuel cells and internal combustion engines. These targets want to generate a positive socioeconomic impact in the Atlantic region to regional industries and society. The duration of the project is 3 years. It started on October 2017 and will finish on September 2020. Besides the 3 basic work packages, coordination, communication, and capitalization, there are 4 technical project work package, the previous I told before. Now I'll tell some examples of each one. Within the first work package, the University of Cantabria has done a study of the recovery of hydrogen from industrial waste streams, and this can be from captive industries, which hydrogen is used as raw material, but the installed capacity exceeds the internal consumption. Or it can come from byproduct industries, that the hydrogen is not used in chemical processes or any process, and wants to be used in more efficient fuel cell, internal combustion engines, or to manufacture high-value products. There is an estimation that the hydrogen losses in the European zone is around 900,000 tons of hydrogen per year, and in the Atlantic area, around 100,000 tons of hydrogen per year. The main industries that can be used for this are steel plants, which produce coke oven gas, mainly composed with hydrogen, around 50 and 60%, methane, and some carbon monoxide. The refineries produce methanol and syngas. Chloralkali has a very purity hydrogen, more than 99%, and from ammonia plants. There are different technologies to purify these waste streams, and can be membranes, pressure swing absorption, or cryogenic distillation. However, the last 2 ones are with high capital cost and energy consumption. Another way to recover hydrogen can be with photocatalysis. This is based on photoactive particles, such as titanium dioxide. When the light excites these particles suspended in the solution, an electron-hole pair is created, and the electrons combine with the solution, producing hydrogen and oxygen. This can be separated with membranes. It's an inexpensive, non-toxic, and chemically stable technology. However, there are some drawbacks, like high combination rate, difficult contact, and recovery. For improve this process, you can optimize the operational condition like pH or photocatalysis concentration, or use different materials like graphene oxide, platinum nanoparticles, which are more expensive. Another option is to produce hydrogen from renewable energies. For this reason, the University of Cantabria has bought an electrolyzer with a stack of 5 PEM cells or a single PEM cell to test different cells, membranes, and catalysts. These are some examples of the results on polarization curves and efficiency of different catalysts. On the other hand, the University of Porto has developed a CFD model of a PEM electrolyzer. First, a preliminary version, more simple, and now we'll develop a second version with a more realistic geometry, with degradation mechanics included and more complete. Within the second work package, the Austin University, which is specialized in safety hydrogen, are doing many tests at different conditions, different fire attacks, and also developing a 3D CFD model to validate the experiments. They have patented an explosion-free composite tank for compressed hydrogen storage. The 3 layers are an inner layer that is impermeable to gas, but at a determined temperature, it becomes gas permeable, around 120 degrees. An intermediate layer, which bears all the pressure of the internal pressure, at least 700 bar, an outer layer, which is thermally protective, that lower the thermal conductivity of the intermediate one. When the vessel is attacked with fire, the outer layer reduces the degradation of the intermediate layer to withstand the internal pressure until the liner gets the determined temperature, 120 degrees. It melts, and then the gas can bend through the whole surface, and the pressure is reduced in a controlled and relatively safe manner. So there is no explosion. With the goal of innovative hydrogen storage, the University of Porto and LNEG are studying sodium borohydride chemical hydrate storage to be used in marine system and coastal infrastructure. They have developed the design of our reactor, and Asilva Mato has done the numeric simulation and has built up the reactor. The red things are the catalyst foam to enhance the conversion in the reaction. They can be put and extracted easily with baskets in the whole diameter of the reactor. Within the third work package, the Ulenco company are studying the implementation of diesel dual fuel engines, first in light commercial and heavy commercial trucks and vans with a conversion strategy, and we'll do the same with a Cygnus ferry in the Orkney Islands. They are also testing a 100% hydrogen engine with 6-cylinder in their test laboratory to promote high performance and efficiencies and with low emissions. On our side, the University of Cantabria has set up a collaboration with Public University of Navarra in a Volkswagen Polo 1.4-liter spark ignition port fuel engine. It had been converted to work with hydrogen or methane or gases. And we've done some experiments with pure hydrogen, pure methane, and coke oven gas. Coke oven gas, as we said, has 57% of hydrogen, 30% of methane, 6% of carbon monoxide, and some inert gases. The first experiments have been done, and we can see the power performance is very good of coke oven gas. On the other hand, for fuel cells, Auriga has developed the UK's first fuel cell in Bristol and has been operated for hundreds of hours in all environmental conditions from freezing to above 30 degrees. Finally, in the last work package, Apria Systems, Esther, can you tell more about this, has done 2 surveys to review the state of knowledge on hydrogen risk, cost, and benefits in this area. One has been done to general public survey, and the other to stakeholders. For example, the perceived costs, risks, and benefits for hydrogen marine applications for the general public survey has been very positive. And for stakeholders, the expectations regarding the medium-term market implementations has been focused more on portable power generators, vehicles, and hydrogen refueling stations. They will also do a life cycle assessment of fuel cells for the implementation. To finish, I was just to invite you to International Summer School in Hydrogen and Fuel Cell Technology in Portugal in 22 to 26 of June 2020, organized by Alexandra Pinto. It will be based on hydrogen fuel cells fundamentals, hydrogen production storage, devices and applications, mobility, advanced materials, modeling, safety, and life cycle assessment. These are all of the partners, so if you had any specific question, you can ask to anyone. Thank you very much.